Cecilia Levy is an associate professor at the University at Albany and associate chair of the UAlbany physics department. She got a Bachelor of Sciences in Physics at the Universite de Montreal, a Master of Sciences in Astroparticle Physics at the Queen's University, and a PhD in Astroparticle Physics at the University of Münster, Germany. Her primary research interest is in astroparticle physics and the ongoing effort to directly discover dark matter, an elusive particle which makes up 25% of the universe. She's part of the LZ experiment, a 7-tone detector which will be the biggest dark matter detector ever conceived, with a truly good discovery potential. She's also an external collaborator of UAPX. So without further ado, let's welcome our guest. Hi, Professor Levy. Welcome to Unmistakable.
Hi, thanks for having me.
Thanks for being here. So happy to, and very excited and thrilled to our conversation. So how are you today?
I'm fine. It's Friday, so I am fine.
Great, exactly. So let's start from you. I'm very curious to know, and also to let our audience to know when did you start? How? What did actually trigger your curiosity into physics and into particle physics?
Okay, so that's a bit of a sometimes people are like, come on, that's so cliche, but it's true. So I actually wanted to be an astrophysicist when I was 9 years old. My dad had gotten me some astronomy books, and I was a very avid reader from a very young age, and I devoured them. And so I was this little 9-year-old going around saying, I'm going to be an astrophysicist. And back in the day, you know, this was something that what I usually got was, yeah, that kind of job is not for a woman. And so that, you know, there was, I think, a bit of a like, well, I'm going to show you. But also I had my education in France. My high school and my K-12 was in France. And so there you are exposed to physics, chemistry very early on. And as soon as I was exposed to that, I was like, yeah, I just love it. And so I kind of never budged from that. And I remember always having in my bedroom this sheet of paper that was saying, here is the path to become an astrophysicist, telling me what I needed to do, etc. So then after high school, so I went to college. I knew I wanted to go to college in North America. My English level was not good. So I did 2 years in France first, and then I kind of jumped. I went to a full English college, and that did not work at all because I just wasn't good enough in English. So then I went and I did my bachelor at the University of Montreal. And then by that time, my English was really good. And so then I did my master's in Queen's University in Ontario in Canada. Then I came back to Europe. I actually did my PhD in Germany. And the thing, though, is that I remember in college, when was the first time that I actually took a real astro class because I wanted to be an astrophysicist. And I was like, oh, I don't actually like that. And so that's how suddenly I did not become an astrophysicist, because I realized that the astro part was not what was really making me tick, but the particle physics was. And so that's how I bifurcated into this. And now the reality is that I'm an astroparticle physicist. And what's really funny is that I'm actually in the middle of preparing a full astronomy class for juniors that I'm going to be offering next year. And so I still kind of get to teach what my first love was, right? But yeah, I've always kind of stayed in that path.
Yeah, that's a beautiful story, actually. Very inspiring. It seems that you cannot get rid of the astro part.
Yeah, that's really what it is. That is really what it is. And then I wanted to be a theorist. Every person who actually studies physics wants to be a theorist. And because you don't know what it is to actually be a physicist. And also as a woman, you know, I thought experimental physics is for men, right? It's for boys. Like boys are the ones that tinker with things, and I get dolls, right? And the reality is that I was like, nah, this is for me.
That's so great.
And so yeah, so that's how I became an experimental physicist. Yep.
Wow. And I think also you said that you are preparing a course now on astronomy, right?
Yes.
And I think since you realized at a young age that you didn't like that, that was not your mission, you know, it's also, I think, you also are in a very good position from an educational point of view to teach it, because you probably need to find the inspiration, need to find how to inspire young people.
Yeah, that's very interesting that you say that, because I actually really do believe that a lot of my college years, there were classes that I didn't like, not because of the content,
Mhm.
but because of the teaching. And you know, physics is a very non-diverse field, and there is this saying that I absolutely hate, which says you have to think like a physicist. And I'm like, that means that we're all thinking the same way. That's exactly not what science is. You want to think in different ways. Of course, you want to understand the underlying physics principle. Of course, I'm not saying I'm going to redo Newton's laws, right? But while understanding the physics principle, you also have to be free to be creative, and everybody thinks in a different way, and that's the beauty of diversity. And so I actually think that physicists have hurt themselves with this just one-minded way of thinking
Yeah,
and
absolutely.
teaching.
Absolutely, I agree. That's actually, it happens in a lot of areas, not only physics, but sure. So let's jump to, for example, your area of expertise.
Mhm.
What are you currently studying? What's your area's focus?
So I'm an astroparticle physicist, and I'm an experimental physicist, and my area of focus is the direct search of dark matter, particularly with the Lux Zeppelin experiment, which is the best, most sensitive experiment in the world. So dark matter, if you're not familiar with that, or the viewers aren't familiar with that, that's 25% of the universe. So if you look at the universe and you look at everything that you know, like that you see, not that you know, that you see, through observation, so your galaxy, gases, all of that, it's only 5% of the mass of the universe. And so that's what I always start my lectures with, is saying, all right, so you think you know, you think we know.
Yeah.
Well, at the end of my lecture, you're going to realize how much we just don't know. And we have to accept that really haven't even started discovering the universe, frankly. And so we're babies, really. And so the dark matter is thought to make up 25% of the mass of the universe, and then there's 70% that is dark energy, which is a different story, and that's not what I work on. But what we think with dark matter is that it may be made of some particles, and the tricky thing is that they don't interact often at all. Very, very rare interactions, but what you learn really quickly in physics is that zero doesn't really, there's never really a 0% probability of anything, which means that even if these particles interact very rarely, they do interact sometimes.
Hmm.
And so if we're smart enough, clever enough, maybe we can see them interact with our detectors, even if it's very rare. And so that's what we're trying to do, because while we know that there is this dark matter, or we think we know, because we have a lot of observational proofs, and those observational proofs are through astronomy.
Hmm.
The reality is that we have no idea what it's made of. So what I always say, I really like that analogy, because I think it speaks volume. It says, if I ask you, how do you know that the wind exists? How do you know?
Well, I perceive the effects. I mean, I cannot see it.
Exactly. And that's exactly the same thing. So we know dark matter is there because we see its effects. But if I tell you what's the wind made of, you don't know. You've never seen the wind,
Exactly.
right? That's
Exactly.
exactly the same thing. And so the wind is our dark matter. And so we're trying to find a particle that it's made of, because the thing is that until now we had models that were kind of like, oh, it's just going to be one thing. But the reality is we don't really know that. There could be different particles there. We really don't know what it's made of. So we're just trying to find something and then go from there.
Of course, that should be the scientific approach, of course.
Right. Yeah.
And
so
I'm sorry.
So, no, go ahead, please.
And I've heard from, for example, from Professor Shedagas, you know, that there is stigma, something that I didn't expect. There is actually some stigma in the scientific world concerning dark matter. You know, there are scientists that are not convinced that and don't think that it's probably worth to study it.
Yeah, and so it's funny because it's really there's such a parallel with UAPs there.
Yeah, I know.
which is that I can understand the questions, and I welcome the questions. I think that some questions that are being put forth from a skeptical point of view are very much worthy. And, I think we've done a good job disproving why this is not so. But, it's true. You still have people who doubt that there is dark matter. And maybe our models are completely wrong. I doubt so, because everything else kind of works. So we must at least have some little bit right.
Yeah.
But what I cannot understand and I cannot agree to is this, oh, well, we shouldn't study it. No.
Of course.
That I can't agree to. I can agree that you're skeptical. I can agree that you have questions, and I welcome those questions. But if your answer is, oh, this is a waste of time, we shouldn't even look into it, then that I wholeheartedly disagree with.
Of course. And that's, as you said, is probably the same thing that is happening also to UAPs, to the study of UAP. Yes. Many people insist there's nothing there. I mean, they are skeptic, and so therefore they are not actually, they don't want to study it. They don't think it's worth studying.
And to be fair, what's actually a little bit ironic is that on the UAP side, I'm more on the skeptic side.
Yeah.
I think a lot of it is mundane things that we just have not figured out what it is. I'm sure we're going to get into that.
Yeah.
But of course we need to study it. Of course, to me, this is the essence of scientists, of being a scientist, right? Is that you see something, you can't explain it, you want to know what it is. That's why you go into science. You don't go into science to believe in something. It's not, you don't have this ethereal thing or this must be there or must not. Science is about the scientific method. It's about show me the proof. Show me the proof, and then we can explore, try to understand, put an hypothesis to the test, take more data, validate or invalidate, right? But you have to look into it. I don't understand the closed-mindedness. To me, anything must be studied. From the moment that there's a question, the question, it's funny because often you're going to hear teachers say, oh, there are no stupid questions. And the reality is, what I think the reality of it is that, yeah, there are no stupid questions. And also, there are no questions that do not deserve an answer. And that's really the key, frankly. Yeah. And so that's why I'm into this.
I agree. I totally agree. And I actually think that it's very important to have also these scientific skepticism towards anything, of course, and including UAPs, So, but it's so, I guess, noble and important, of course, that you still are actually involved in this, and you put all your efforts to study. So I think that's exactly what we expect from scientists.
Yes, and what I only wished is that there would be more. frankly.
Yeah.
And I think that that's the issue I find is that right now in the UAP field, honestly, you have a lot of pseudoscientists.
Yeah.
And that's a huge issue.
Yes.
And there's many people that I don't even want to interact with. I'm like, I'm sorry, you're not doing science. You're pretending because you think that makes you sound interesting or cool, but you're not. And so, I think that that's one of the biggest issue in the field is all of these people who are actually damaging um, uh, the studies of UAP, because they must be studied. I mean, they have to be. Even if, which I don't think is the case, and that's just based on a statistical point of view, and also from what I told you earlier on, which is I know we know nothing.
Yeah, exactly.
The universe. I really highly doubt that we're the only somehow semi-intelligent species in the universe. Whether they come and visit us, I don't know. But from that point of view, you want to know. If you see something that you don't understand, you want to understand it. And also, it's, to me, it's always like it's always flabbergasting, because you've got some little thing that's going on in the sky, and it's actually been reported by people that are trustworthy, and instruments that don't really have a human bias in there. Aren't you kind of curious what's going on in your sky here? I mean, I'm like, the government is barely starting to talk about it, and I'm like, how are you not pouring billions of dollars into this? I'm like, we ended up with a Chinese balloon overhead.
Yeah, exactly.
Okay, just why aren't you studying that? It's just, to me, this is something that's completely baffling.
Yeah. And even the slightest chance of a possibility, should trigger our energy, our investments, and our efforts, because that would be, if true, that would be the most important, probably one of the most important discovery of all time.
I agree. I
So
agree. And also, I mean, if you look at it in terms of civilization, there's there's some sort of categories with how civilized the world is, and we're still at planetary, because we really haven't left
yeah,
Earth, right?
exactly.
And now we're gonna go to Mars. Okay, it's going to be in a few years, and it's already quite technical. Is there any chance that we can go outside of the solar system right now? Not a chance. Not a chance in hell. Okay, we've got Voyager that's continuing somehow to send data after 50 years or whatever, which is great, but we can't go there, right? We still have so many scientific and technological hurdles to go through. And so yeah, I mean, to me, again, I don't understand that. Maybe there is, but I don't understand that there isn't a branch of government that just pours money into this, and would bring in the best minds on the planet to try to figure this out, because that would be such a jump. And also, it's a societal thing, because I mean, the planet is overpopulated. There's going to be a moment that there's not going to be enough space, that we're going to need to expand, and I mean, this is the same thing as Christopher Columbus, right? Why is it that suddenly they went and discovered something else? Well, because Europe was starting to be a little crowded. And now the planet is a little crowded, and so we want to go somewhere else. So I think that if you could somehow make contact, assuming that they're friendly, and but at the same time, if they wanted to kill us, we would all be dead already. So
exactly.
I don't know. I just, if you have, my guess is, if you have the technology to come to this planet, you have the technology to obliterate us. But so we should be making contact if we could, and learning as much as we can. So again, still don't get why this is not more. I don't understand why this is in the crackpot area,
I know.
Actually, to me, one of the most fascinating aspects around this topic, which actually triggered my curiosity involvement, is the an enhanced comprehension about us as humans that this whole topic gave me. More the, of course, we don't have me particularly, but also I think scientists and a lot of people don't have a real clue of what's going on. I mean, we haven't seen a non-human intelligence in any moment of our life, so we can only guess. But we will always guess wrong, I think. And
Yes.
but this whole topic really taught me how we are as human beings. So for me, it's really complicated to understand why are we not pushing to understand it, to try to why are we actually dismiss everything, a lot of things like dark energy, for example. Why is it possible that we are not so interested? It's not the most important thing to try and understand what is the universe is made of, and we ignore it.
Yeah, I mean, to be fair, both dark matter and dark energy are being studied now quite heavily.
Yeah. I know, of course.
But yeah, no, but I see your point, and yes, I agree.
Yeah,
I
and
agree.
also what you said about sensor, I really liked it because, for example, I happen to travel for my previous career a lot by plane, and also get to know a lot of pilots. So I tend to trust them because I have many friends. They are really solid people. Of course, the fact that everybody can misinterpret something, you know. But for example, I learn how these radars and all the devices are commonly used for um, everyday travels, you know, and they don't fail so often as the the bankers would like them to fail. You know, whenever there's a UAP, it's always a radar glitch. Whenever there is a, so even if there are thousands of sightings, you know, it's always a matter of a problem with the radar, with the sensor. And I also think that that's not really realistic. Of course, that can happen, and we will discuss it in the paper too, you know, but it's not on a daily, I don't think it's on a daily basis. Whenever you get something, it's wrong. It's not like this.
I agree. I think that the main issue is that this has really been taken as a non-serious thing.
Yeah.
And so trying to be somewhat politically correct here, but you've got all of the nutcases and crackpots who've jumped on the bandwagon, and now it's the same thing as conspiracy theories. And the problem is it's been going on for so many years and decades that it's really, once something is in the cuckoo clan, it's really hard to
Take it out.
take them back into a sensible approach, and a scientific approach. And I think that that's really is the hurdle we are facing, because right now, what is being right now the problem is, I always say that the report from your drunk uncle in the park on a bench one night counts the same as the report from a very awake pilot, jet fighter pilot who's up in the sky, someone that we trust with the defense of our country. And I'm like, how are these two equivalent? They're just not. One, I don't want to even care about. I'm like, okay, sure. But the pilot thing is a very different things, right? And so what again needs to happen to me is, the issue is that right now we do UAP by happenstance. So what I mean by that is that someone somewhere is doing something else, and then there's a UAP or something, and it happens to be captured by something which was not there to look for UAPs.
Yeah.
So then you're like, oh yeah, but there was that other thing, maybe we look at it. And what the scientific method says is that, no, what you should have is something that is looking for UAPs, so that when they happen, if they happen, you are ready. You have everything calibrated properly there. You know exactly what your equipment is. And so what you're doing is running an experiment.
Yeah.
And this makes me think of so there is the oldest radiation that you get on Earth that was emitted about 380,000 years after the Big Bang. So it's very, very old. It's called the cosmic microwave background. Anyway, I won't bore you with the details, but when that was discovered, that was by happenstance. So there were two people that were looking for something else. They had a big antenna. They were looking for something else. And then they kept on saying that signal in the microwaves and being like, oh, what is this? What is this? So this was completely happenstance. And the problem is that, so how did we found the CMB? Not by just saying, oh, there's something else by happenstance. Is saying, okay, now let's turn everything to this. Let's tune all of our measurements, all of our experiments to this and try to understand what this signal is. And I think that that's exactly the approach that needs to be done with UAPs, right? Which is not wait for them to show up. I understand that we don't know when they will show up and where. I get it. But then set up a bunch of experiments,
be ready
everywhere, and just look for that, not for something else, for that. And also learn by doing so, learn to be able to identify what maybe you think is a UAP, but is not. And you know, this is something that I can see. It's not that hard to create an AI ML software that can comb through data and say, oh, this is most likely this. This is most likely this. Okay. Identification. Is it going to be right 100% of the time? No. And then when it's not right, that's when you send it to humans, you know, to analyze the data. But the problem is that to be able to do this, you have to know how the data was taken. You have to have a scientific protocol, a scientific procedure on what equipment are you using? How is your equipment calibrated? Calibrating meaning that you understand 100% your equipment. You know that it's going to do exactly this with this error margin, because everything has an error margin. The problem is that right now what we've got is people with their cell phones. And I'm like, I don't know what you were doing at the same time. I don't know if there was probably a light source next to you. Who knows, right? Yeah. So it's really important to have these experiments set up for this purpose, and none of them. And that I don't know how to convince anybody to do that.
Yeah, I know that's a very difficult task. But talking about science, and so let's talk about the future, not about the past and the stigma. And so I have here your paper, you know, yes. Initial results from the first field expedition of UAPX to study unidentified anomalous phenomenon. I took a bunch of notes, and if I understood correctly, it's in pre-publication, was submitted to peer review.
Right. So right now there's some corrections that are being done to it, which is the normal process. So the peer review process, and that's something that I really want to take a second to explain very clearly what that is. The peer review process works this way. You write a paper based on what you've done, and then you send it to a journal. The journal has an editor. That editor will then find proper scientists, you know, professors within the field or a closely related field to read that paper and review that paper. This is why it's called peer review. Then those reviewers send you back comments. They send them back to you do not know who those reviewers are. It's completely anonymous. Yeah. So they send back their comments to the editor, which then send them back to the author. Then the authors can respond to the comments, will usually correct the paper, so often the comments are going to be something like, well, you have not addressed this, and I think this needs to be addressed because that doesn't answer the question. What about this? Or sometimes it's like, I disagree with your conclusion.
Yeah.
And then you need to have a real discussion and say, okay, how do I convince that reviewer that my conclusions are correct? Okay. And it's all about, you know, if a person is doubting your results, that means that you have not presented your results well enough. That's why the peer review process is very lengthy. And that's why it's so important, because you really have a review by your peers that are really looking at the paper and analyzing what they're reading and making sure that the quality of the paper is as high as possible. And often now, again, in the UAP community, that's the new fad of people saying, oh yeah, this was peer reviewed. I'm like, no, it's not because you put it on like Medium that it's peer reviewed. That's not what peer review means. Yeah. And so again, I really want to try to detach the scientific community from, again, these people who do pseudoscience and are not helping at all.
Yeah, absolutely. And actually,
so we are in the correction phase for that paper
right now. Yeah, and also the peer review process takes a lot of time, and also, of course, the scientific analysis takes a lot of time. The expedition was actually in July 21, I think, 2021. Okay, and of course, it took years to analyze all the raw material that you recorded, hours of recording, and
it's not all analyzed either.
Yeah, I know.
But I think that yes, and the issue, of course, being that, you know, there's no money for it, there's no support, and so it's that's why it takes even longer. Yeah. But that's one of the issue, is that we live in an age where everything must be done right here, right there.
Yeah.
Now. And the reality is you cannot rush science, and you have to take the time to do it properly. And that takes hours and hours and hours and hours and months and years. And so people don't understand that. But the reality, I always say, I'm like, sorry, science is boring. At today's pace, science is boring. No, you're not going to get a result in a day. You are going to get, if you get a result within a year, that's pretty awesome already. You know? So this is really something that I really wish the public understood a little bit better, that to do good science, you must take your time.
Yeah, and this is true, in my opinion, for everything in life, you know. And so we are losing that perception, that actually understanding, because to make a great movie, a great film, or a orchestral piece, or you know, whatever, you need to spend endless hours, very boring hours in your house, and
Yes.
and not fun, not going to events. So it's really a very long process. And today, like with social media, everybody expects things to come out in a second, you know. And if they do come out in a very short time, that means that there's a lot of money, and beyond that, you know, there's a big production.
And people power.
Yeah, exactly.
Power, right? And again, that's the thing, is that right now, where do you go and ask for funds for this? There's no place that you can go and ask. Nobody will take you seriously. Yeah. So that's why, in fact, the movie was a movie, right?
Yeah,
because
exactly. It's commercial.
We wanted to pay for it.
Yeah.
But the problem is that, you know, this is again, you don't do science with Hollywood. I'm sorry, it doesn't work that way. You do science with, you know, a proper plan of action that, again, lasts years. And the problem is, of course, when, you know, you have these TV shows, etc., it's all about sensational. It's all about making sure, you know, you throw some like cool words in there and try to hook your audience, and that's what you do. but you're not actually going for the truth, and
Yeah.
certainly you're not going for the scientific method.
Yeah, and that's also it's great that you said that, because it's also part of the problem, like you suggested before, because some like that also people get kind of used and convinced that we will know something about lots of mystery, in this case UAPs, whenever we see like a smoking gun proof. And maybe that's not the way we will discover about UAPs. It will be like an inference, a little partial data which is confirmed and which let us know that that's not ours, you know, but not the
Yeah,
other way, you know, necessary like a giant triangle UFO showing up in the you know, in an afternoon in New York.
right. Exactly. That's
Yeah.
exactly right. That's exactly right.
Yeah.
So
Okay.
yeah, and so we have to be, I mean, presumably, if there are other intelligent life forms that are visiting this planet, they're smart enough to
Yeah,
hide,
exactly.
to, if, you know, they show up in the middle of New York, that's because they want to.
Exactly.
And I mean, I don't know if I'm putting myself in their shoes. If I could, I'm not sure I would want to.
Yeah,
To be
exactly.
perfectly honest. And so yeah, so we have to infer it. We have to,
Yeah,
it's a chase. It's actually
yeah,
very exciting. You
absolutely.
know, in my field of work, we call it the hunt for dark matter. This is the same thing.
Yeah,
We're hunting.
yeah,
Uh,
absolutely.
but yeah, and it takes time.
Yeah,
It takes time.
and I also think that realizing that something is true by inferring it, you know, it's much more, it's much smarter and probably rewarding than just seeing in plain sight, you know.
Yes.
Or-
Well, for my generation,
yeah,
yes.
yeah, I agree.
That's, you know, this is funny because going back to education as
Yeah,
a professor, I see it in the students. The I'm going to sound like a really old person, but the phones, the fact that every 18-year-old has been taught that you have a question, you pull out your phone and the Google will tell you.
yeah. Well,
And the problem is that that's what they expect out of life now. And so
mhm,
you have a new generation of students who don't think at all. Why would they think?
yeah,
The answer has always been in their pockets. And you know, we don't teach our children as a society to think anymore. And so that's why they want things immediately. Like, for example, even the length of a problem that you give them in class, uh, if it's more than 2 lines, it's
yeah.
too long. They don't want to read it. It's, you know, it has to
Hmm.
be less than whatever how many words a tweet is. I mean, it's crazy.
Yeah,
And I really do think that while social media and having a phone in your pocket that's a really great computer right there that allows you to have, it's
yeah,
great for certain things. I think that it also really does a huge disservice for the education of our society. Now we have a society that is dependent on these machines.
yeah.
And I think that's a problem, frankly.
Yeah, I think the same. Actually, they are tools, very powerful tools, but the the, the more the tool is powerful, and the more responsibility is needed to use it.
Yeah,
So
that's
that's so about the paper, and a very interesting thing that you also mention in it is that, of course, this is a new field, a still nascent field of art science-based UAP studies. And what I really appreciated about it is that you are really tackling down the problems of how do you capture UAPs. So you are experimenting with different sensor, with different technique, seeing what works and what not. And so could you explain us a little bit what's most important for you in this paper from a scientific point of view, also for future studies?
To me, what's in the paper that's the most important is that it's almost at the very end, is that it establishes what a discovery actually is and what an anomaly
Yeah.
is, And this is really taken from the field of particle physics. So in particle physics, when you take data for whatever it is that you're looking for, okay, let me go back to dark matter. Okay,
Sure.
imagine we see one signal, one signal that looks a little weird. Is this enough to say this is dark matter? No, it's just one, right?
Yeah.
What is our error? If our
Mm-hmm.
error is plus or minus 1, then it's as likely that it is something that it isn't. It's not conclusive. So what we have is, in particle physics, we have this 5 sigma discovery, which means that you need to have in lay terms a much bigger set of anomalous points, if you want, to say whether something is or is not. And then in between that, you say, well, we can think this at this confidence level, which means we're kind of confident that that's what it is, but we're not 100% confident. And 100% confidence doesn't really ever exist either. And so, for example, in dark matter, like I was saying, is that if you see one signal, you're like, maybe, maybe not. You see 5 signals, you're like, there seems to be something there, but you see 100, there you can be pretty confident that there is something, right? And so that's the same thing that you need to do with UAPs, is that when you see something, how sure are you that this thing is not something completely mundane? And I will say that for UAPs, it's much more difficult to do that because often the data is going to be just one point in time and space, right? Yeah. It's an image, it's not a clear signal like we have, for example, in a dark matter detector, where you have an interaction. Oh, something went boom like that with something else, right? So it is more difficult, but it's absolutely not impossible, because you look at your data, you say, okay, I'm looking at say at this portion of the sky, and I've looked at it for 3 months and there was never anything, and then one day there is something, and then it goes back to 3 months of not being anything. You hear what also I'm saying 3 months, I'm not saying a week. And I think that's the key thing, is that, so I think that the expedition that UAPX did to Catalina was good, but there is nothing you're going to get out of this. Nothing. It wasn't long enough. It's in an area that is super populated. The equipment was not calibrated. There were film crews going on everywhere. You can't, it's not, the paper is really not about saying, ooh, look, UAPX found something. Because here's the reality, they did not. And I've said this since the beginning. There's nothing that was found that's anomalous in there. I'm sorry. And if there is something that cannot be explained, it's probably just because the data was poorly taken, and that they did not know their instruments enough. But it's not because there was something going on. And so the thing again is that to be able to really tell that there's something that's anomalous, you need to understand what normal is, right?
Which we don't, because I think, I mean, of course, we know it. I mean, if we see a plane with our eyes, it's a plane, but sensor doesn't, we never use sensor just to identify what we already knew.
Right.
Well, that's not true. I mean, of course, sensors are used for this, but we had never, I think this is the first, to my knowledge at least, one of the first studies, if not the first, to really do this in a very scientific and methodic way.
Yeah. And so the 2 conclusions from the paper really is that, number 1 is that you need to categorize what you see and stop jumping to conclusion and saying, oh my God, this is an anomaly. Something's no. Okay, you need to have this accepted before saying, oh yeah, there's really something that we do not understand. You have to have enough data, and you have to be sure of that. Okay, and the other thing is that you need to understand your equipment.
Yeah.
And equipment, no equipment can ever be deployed until it's been calibrated. And calibrated means that you've taken normal data. Like, oh, here, so for example, how would I calibrate a camera? Okay, I take a camera and I put it outside my house and I take data for a year and I see what always happens, and then I can see the birds, the rain, the whatever you want. Okay, and then what you see is you can say, okay, this is in the realm of normal. And then if something happened at some point, just one time, that becomes the realm of not normal. But does that mean that not normal is UAP? No. It just means that something happened that you usually would not expect to happen. So you can say this, you can say this in terms of expectations. So I expect that if I take a camera in my backyard, I am going to see 15 planes a day. Okay. And then there is one day that I see no plane at all. Why? Okay. That's how
reasons. Yeah.
Right. But that's the normal would be, okay. So now if the one day you don't see planes, does that mean that, I don't know, there was an attack on the airport, or does that mean that most likely there was a snowstorm and the local airport was closed, right?
Of course.
But so, however, you would not expect to see 0 planes. So that would be initially, but that doesn't mean that it's outside the realm of impossible, of possibility. It's still not an anomaly. It's just an outlier. That day, there was exceptional circumstances that meant that you didn't see 15 planes flying over your house.
Of course.
That's what we have to do. And you cannot do this without time, without a lot of data and a lot of time. And of course, with the added complication that you never know where UAPs show up.
Yeah.
And then, some people will tell you, well, that's why there are hubs. Are there though? I don't know. I'm really not convinced, because again, there's so many things that are known. And when you say, how do you know them? Well, because I've talked to this person and he knows, because he's talked to this person and they know, and this has been known for 50 years. We know. These are old wives' tales. Again, how do you know that this is a hub? Do you have documentation? Do you have a clear, numbers of events, rate of events, so that, if I put something there, I should expect this, that you're going to have this anomalies per whatever days or something. So again, I think we have to be very careful with this. And so, look, I don't have a better solution than to say, oh, well, we should start with those hubs, but still taking this with a grain of salt, right?
Yeah. I think the odd spots are probably, how can I say, the kind of something that we can try, because it's something that we think that it could be, like where is more likely, for example, for these to happen. We don't really know, but some things say, some kind of data says that there's a high percentage of sightings there, so it could be worth a try, of course, but it's not as scientific. It's not a certainty. And about the data that you were referring to, of course, I spoke, for example, with Michel Vaillant, who was working for the Japan in France, that you probably know. I mean, the organization. And for example, last time I spoke to him, he was the person in charge of basically creating the database, the computer database of all the cases in France. Of course, that's only referred to France. But and now is developing a software that hopefully will allow other scientists to at least get to know this data, which was, in his opinion, collected in a scientific way. Of course, not probably all things, because some things will be anecdotal or similar, but there is data that could be used, But also this could be, of course, I think there's a lot of data that probably we don't really know about. That's one side of the coin. And the other, of course, here the problem comes with people like David Grush, and if these allegations are real, it seems it's evident that that somebody is hiding information. So if this information exists, well, that could be the place, to, that could be a very valuable information for scientists instead of going back from scratch.
No, I agree. And I don't know, look, I don't know what the government is or is not hiding.
Of course, nobody knows.
I have no idea. But I think that you make a couple of really good points. So there's one thing though, just jumping back for a second as to the hubs and where to go. When you're looking for something that's a rare event, you really don't want to be looking where you have a lot of background noise. And that's one of the issue, is that, for example, I'm sorry, I understand why the expedition was in Catalina, but literally that is not where I would have gone and taken my first data if it had been up to me, just because you have so much pollution of background noise, everything else. So, if you really want to start doing this, you really want to go in a place that is not populated. And so you still can, at some point you have to start somewhere. And so you can look at, okay, is there, I don't know, some place lost in the middle of the desert where there seems to be stuff. And then that's a better place to start, because you're most likely, you will lower your background if you want. And so looking at something very rare, it's really important to lower the background, because the more things we see, the more likely we are to say, oh, I think I saw a UAP. I think this is anomalous, when really it isn't. So that was the one thing. The other thing is, these databases, there's somebody else in Germany that's doing one as well, that's doing a reporting system. And I think that it's really good, because that's needed. I think this is something that's needed, maybe not even really for the scientific analysis, but for the demystification of the field. And I think that my biggest issue is because we are saying UAPs are taboo, frankly, because of the stigma. And you hear this often when the military people talk about it. They say, oh, I kept my mouth shut, I was never going to get my promotion, or something we're going to think I'm a fool. And I think that's really the biggest issue, is that if we encouraged people to talk about it, rather than, if you say anything, you're going to be considered a nutcase and you're going to ruin your career, I think we probably would end up with a lot more credible reports, right? You will always have the crazy person who saw something and that, okay, fine. But I also do think that there are a lot of non-crazy who have seen things and have never said a word about it because of the stigma. And so I think that that's really one of the big words. And where I really would love to see this happen is in the military, in the government, right? So that these are people that most likely, if they said they saw something, it's recorded with something or another, some equipment or another. And so it's verifiable. You can see that there is something, okay? You maybe can't identify, but you can see that there is something.
Yeah.
And so I think that, you know, if again, change is slow, and convincing people that they can speak out freely on a subject that has been stigmatized for decades is going to take a very long time. And I think initially you are going to be flooded with the crazies. But I think that that's really the number one goal. And that's what those sort of database, I think, help, because people will start probably entering anonymously. Now, the issue with the database, and that's why I keep on saying that what needs to happen is an actual experiments.
Yeah.
The
Absolutely.
issue with those databases is that you have zero control on how the data was taken, right? You don't know. People will say something, but they've done something different. I'm not saying that they're lying necessarily. I'm just saying
Yeah, I
it's
understand.
right. And so again, that's why you need to have a procedure, a process, and equipment that is dedicated to that. And when you think about it, it's not that ridiculous. I mean, again, what my line of work, we've been looking for dark matter for like what now? I don't know, 40 years, something like that.
I think so.
I mean, and we keep getting money to build these huge detectors,
Yeah.
right? For that, they're
Yeah.
not detectors to do something else. We like thinking outside the box, so we also always find like interesting others physics to look at, right? And other scientific studies to do, but it is a dark matter detector.
Yeah.
And so if you can put several $1 million in something like that, why can't you put several $1 million in a UAP observatory?
Yeah.
Which again, same thing is, you know, when we've looked at the night sky, I mean, you started pointing the telescope. You don't know what you're going to see. There's a reason that we keep on building. I mean, that there's a reason James Webb costed, I think, a couple billions or something like that. And, you know, okay, we've already looked at the sky quite a bit, but now the James Webb is going deeper into the sky, further away, looking and mapping out the whole sky. And while it's going to give pretty pictures, we're not sure we're going to find something. Of course, we do, because the universe is so vast, and so we always see something new, right? But we do have these equipments that are out there. What I'm trying to say is that setting up an expensive piece of equipment to just look is something we do in science all the time. So why can't we do that for UAPs? That's weird. And when you think about it, when I'm thinking about the Department of Defense, and I mean, you look at the defense budget of the United States, which I think is like, it's, don't quote me on that, but yeah, it's like it's equal to like the next 100 countries' defense budget put together or something like that. I mean, we spend a ridiculous amount on defense. Oh, come on, don't tell me you don't have 100 million laying around that you can dedicate to this. I mean, the money, I think, is there. I think it's just a question of convincing people that this is something worth doing.
Yeah. Yeah, I think it all comes down to education, and that's why that interests me a lot, because you know, people are probably not interested. I mean, the general public is not aware and is not interested, and it's also you know, many people are convinced, of course, that UFOs are just a nonsense because of the stigma that was kind of self-imposed and somehow by, of course, like crazy people, or just people that in the past they were looking for attention. But also, to be fair, also it was imposed from outside. You know, it was just actually it was very convenient to keep it like that. You know, so that nobody was actually going to inquire or also to have interest in this. So I think that educate the population, I mean, people about this topic is very important. And like you said, begin the experiment, because I think that we all want to know immediately, you know, in today's society. So we need to know now. So let's disclose everything we need to know now. But if science really wants to understand these autonomously, like independently, and not rely of any government disclosure or of whatever, they need to actually, science really needs to begin the experiment as soon as possible and have a lot of patience.
I will say this is where, I mean, most scientists are funded by either the government or corporations.
Yeah.
And so the problem is, again, you can't do it without the money, and that's where the money goes. So it always ends up being tied to the government one way or another. You know, unless you find some very rich billionaire who decides to fund you. The problem with that, of course, is the oversight, which is you have no checks in place, so you're at the mercy of whoever's giving you the money. You know, someone comes and says, well, I want you to go say this, otherwise I cut your funds, which is actually something that the government really doesn't do in science. And, you know, I mean, whether it's the National Science Foundation, the Department of Energy, all of that is government agencies, right? And so that's why I always say, it's like, yes, in an ideal world, we would have a patron that showers us in millions of dollars and lets us build a system. The problem is also that you need to have someone who's behind it, because again, this is something that's going to take a long time. Let's even start thinking the time of designing here, 5 years. The time of building here is another 5 years. So you have to fund people for, at the very minimum, 15 years. And that's really what we're talking about. Let's not kid ourselves. We're talking 5 years for design, 5 years for building, and 5 years for data taking. And, you know, and actually another 5 years for analysis. So yeah, this is we're talking about an investment over decades, not something that's going to be done in a year.
And I think the UAP community it's actually very big and very passionate, but somehow this passion should also turn into supporting realities like UAPX and other projects, you know, because I think, like you said, it would be ideal if a big Patreon, like, but that's what technically is it's a potentiality of today's world, you know, that private people, you know, can help also science, but somehow it doesn't convert. It doesn't really happen.
Well, I think that the issue is, again, expectations, which is you're not going to start a project unless you know that you can see it to completion. And so when you rely on donation, you don't really know how much you're going to get, and you certainly don't know if it's going to be consistent, right? If you're going to be staying year after year after year, which again makes setting up an experiment very difficult. And the reality is that even like the huge experiments now, they all started very small, right? So for example, LZ is something like 7 tons of liquid xenon. That's the material that we use in the detector. But it really started with little, you know, 1 kilo chambers, right? So now we have this huge detector because we've proven that we could do the work. So this is, I really think that you could start small, right? But with, again, the expectation that if you have something small, you're probably not going to go very far, right? You can certainly develop some softwares. You can show as a proof of principle that it can be done. And I think that that's what the Catalina expedition did. And there were a lot of issues with it. And again, like I said, I don't think there's not, we're not going to find anything in this, but it was a lot of lessons learned, or very valuable lessons learned, and it was also a proof of principle. And so I do think that if one could really redo something like that better, okay, with the understanding that you're not doing it to find something. Maybe you do, maybe you're lucky, right? But you're doing it to set up the stage. And that's how science moves. And so once you've proven that this works and this can be properly done, then you can make it bigger. And the reality is that if, you know, we had great budgets and in an ideal world, what I think we need to have is many UAP's observatories throughout the world. Not just in the US, not just in France. It has to be a worldwide initiative. Yeah. And what's interesting is that countries can be warring, can be hating each other, and scientists still work together. And you know, I have watched scientists from Israel and from Palestine working together. Yeah. And this is very apropos right now, right? Because when in the end, what unifies us is science. And so I do think maybe I'm a little optimistic and you know, idealistic, but I do think that science is also the way to bring people together, because that's the common goal, and we're all going to work together. And it doesn't matter who sees the first signal, because you will have people from all over the place analyzing it, right? So yeah, so I think that this is what we should strive for. I think we're very, very, very far away from ever reaching that. Yeah. I don't know if this will ever happen, to be honest. But we got to start somewhere.
Yeah, I hope so. But I also think that starting, as you said, it's so important, because we could discover lots of things that we are not expecting, first of all. And to me, investigating something is always a way to, like you said, the most important discoveries sometimes were made of starting from something else, and then they realize that there was something, and they focus on them, on it. And I think that that's actually a good approach, because otherwise we are also stuck with what our brain, like intelligence or with knowledge, suggests us. You know, we want to look into it because we know that there's something, we think that there's something, and we ignore something else. So I think it is very important, and I'm confident that, I mean, I really love the paper, even I love, for example, the fact that you also analyzed, of course, which is normal in science, but took into consideration what could be the most plausible explanation for just one anomalies that you detected, that actually is not yet certain that it is an anomaly, as you said, but it was
not. I can tell you this, it's not.
Oh, okay. Now you have actually updates about it.
Well, I'm not going to say what it is,
okay,
but let's be clear. We would have had this conversation a year and a half ago. I would also have told you it's but what the paper shows is how you should go about it.
Yeah,
is
absolutely.
You should, and this is absolutely the way to go about it, is you should have a list of hypotheses, and you need to cross them one at a time.
Yeah, exactly.
And that is something actually that I think is very important, because this is something that I see all the time in the UAP field, if you want, community. And that drives me nuts, which is that everybody who is in this, let's be clear, that's because we all hope that one day we get to see a spaceship. That's because we've all grown up on Star Trek and sci-fi and X-Files and all of that. And so that's, of course, that's my wish, of course, but that's just a wish, right? That doesn't make it true. And the problem is exactly that, is that when you want something really badly, it's really hard to keep your confirmation bias in check. And it happened not very long ago, actually, with he's an actual scientist, and he was showing that he had observed something And it's like, oh, this, I've never seen something. Look, it's an object that pulsates and it's stationary. And I was like, how can you possibly tell that it's stationary? You don't know. With just your eyes,
Yeah.
it could be moving away from you and you would have no idea. And so then, you know, there was a little bit of analysis going on, and then, oh yeah, actually the object seems to be moving away and it's actually dimming. That's why it disappears. But the problem is that that mistake is very prevalent because people just jump to this conclusion because that's so much what you want to see, that's what you convince yourself to seeing. And if you say, well, no, you know, maybe that thing could be going away, you might find an excuse or some sort of explanation, say, no. So you kind of you almost lie to yourself. You kind of give yourself the feeling that you've done this scientifically when you haven't. And I think that this is really the biggest issue, is to not get sucked into that and to always start from a place of what I call healthy skepticism and try not to jump to conclusions.
Exactly.
Because if you do, it's game over. It really is.
And I see these, honestly, I see these also the other way around with, for example, skeptics. Skeptics, debunkers, because let's say the debunkers that belongs to the community, so UAP debunkers, you know, the jump, for example, for me, this paper is the proof that, yeah, you can't jump to a conclusion and just say it's a bird. You need to test it, you know, and you did, you know, you can say it's just a balloon, you know, like many debunkers on internet do, you know, in a couple of hours, they already got the answer and the case closed, you know. It's not the way science works. And also, I always say that I don't believe in either believers and hardcore believers and hardcore debunkers, you know, because they both have a confirmation bias.
And that's why I call it healthy skepticism.
Yeah, exactly.
Healthy skepticism means that you don't say, no, it's not, but you don't say, yes, it is. You say, I'm neutral, let's analyze and let's see.
Yeah.
And I think that that's really what needs to happen. And you're right, it's you always, and often I will say, people confuse what I say for saying, oh yeah, you just don't believe in anything anyway. And I'm like, no, I'm not in the business of believing. I am a scientist. What I believe is irrelevant. It is not the point.
Absolutely.
It's what's relevant is what it is that you saw or didn't see, right? And I don't know which way it goes, right? But it's true that I also think that so many people in this field know. They know.
Yeah.
They know that they know.
And that's a problem.
And I think that is a very dangerous attitude, because what I literally started by saying, no, you don't. You don't, because nobody knows anything, I guarantee you. The human race doesn't know anything.
Exactly.
And so you don't. And I think that this is really coming also from, there are people who've been looking at this phenomena for a very long time, and that have met so much non-healthy skepticism.
Yeah.
And they have been dismissed.
Yeah.
And they have been ridiculed. Yeah. That now they are entrenched in their belief, and they're no longer, they don't see that they're no longer willing to, you know, meet somewhere in the middle.
Yeah.
And I think that that's a huge shame. It really, really is. But at the same time, I can also understand it. I mean, again, when you've been ridiculed,
we are human.
Exactly, right? It's at some point you say, I'm just tired of hearing this. I've been saying this forever, and now you guys are finally catching up. And I'm like, well, yes, it happens, but it's really important for anyone in this field to really keep themselves in check, no matter how much you wish it were true, right?
Yeah.
I mean, I love fairies, right? I wish fairies were right. It's just, but that doesn't make it true, right? Yeah. So, you know, it's I think that people need to really, really to keep themselves in check and keep others in check, and also accept when they are being kept in check. And, you know, all of that very respectfully, because that's very important. Obviously, you want to work with people,
Absolutely.
but yeah, the reality is if someone says, I saw a UAP, I'm sure it was a spaceship, my first response is going to be, photo, picture, you know, just, if you just say that, I'm sorry, I don't know what you actually saw. And again, depends a little bit on the source on the who says it.
Of course.
But even if, you know, the best person comes and tells me this, I say, well, I'm your friend. I do believe that this is what you think you saw, but as a scientist, I cannot validate or deny what you saw because I don't have the data.
Yeah, but it's also why we as human have science's heart, for example. They allow you to basically have a collective mind, you know, and not just being rely on your beliefs. I think that everybody, scientists to artists, have their own tastes. Believe I'm a musician, for example. I have my own aesthetics. But I don't judge music or art depending on an aesthetic. You know, I try to judge it depending on the quality, on the essence or what I see. But I still can see my aesthetic, you know, I can see it very clearly, but I try not to judge things from it. And I think that, as you said, science is also a way to go out from your belief system and to say, maybe you could believe a friend that tells you that he saw us, or he or she saw a spaceship, and maybe he's so convinced that you could also believe it, but not as a science should pursue another path.
Yes, and I think that's really the key difference. And I do again think that it's important to encourage people to come forward. But it's again, what we need is data. It's not anecdotes. Anecdotes is not data. And the other issue is, you know, the brain is such a complicated thing. The human brain, and we do things as people, as humans, that without even noticing it, right? So, you know, if everybody else says, oh, that thing was shaped spherically, you might want to say, oh, this was also shaped spherically, and you're persuaded that's what it is. And you know, you don't even have to go to something like that. I mean, just when something has happened between two people and you ask the two people what has happened, likelihood you get the same story is about 0. Because were they both there? Yes. Is one of them lying? No. They are both telling the truth based on their own perspective and emotions and state of mind, etc., etc. And that's why, again, that's why you need the instruments.
Exactly.
The people taking the.
Okay, so it was very inspiring, really very inspiring, and nice to talk to you. So thank you very much for being with us, and I wish you the best, of course, with your dark matter search for dark matter, and also with UAPX. And I hope that you can really start the experiment as soon as possible.
Thank you so much. Honestly, this was really such a great chat. Lovely way to spend a Friday afternoon. So thank you so much for having me.
I'm so happy about it. The same for me. Likewise. Bye.
All right.